Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem. Solve y double dash minus y equal to e power minus x sine of e power minus x plus cos of e power minus x, or d square minus 1 into y equal to e power minus x sine of e power minus x plus cos of e power minus x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash minus y equal to e power minus x sine of e power minus x plus cos of e power minus x. Consider as equation number 1. Now we can write y double dash as d square y by dx square minus y equal to RHS part remains the same. Now write d square y by dx square as capital D square y using differential operator d. Now take y common from these two terms. We'll get d square minus 1 into y equal to e power minus x sine of e power minus x plus cos of e power minus x. Consider as equation 2, which is in operator form. Equation 1 in operator form is equation 2. Say f of d into y equal to some function of x. Where f of d is d square minus 1, right? Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square minus 1 into y equal to 0. Consider as equation number 3. Now, we'll find the solution to the homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation, we'll find the general solution to our problem. Right? Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 1, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 1, and the auxiliary equation becomes m square minus 1 equals to 0. We can write this as m square minus 1 square equal to 0. This is of a square minus b square form, right? So we can write this as m plus 1 into m minus 1 equal to 0. Now equate each factor to 0. When m plus 1 equal to 0, we'll get m equal to minus 1, and when m minus 1 equal to 0, we'll get m equal to 1, right? M equal to minus 1 and 1 are the roots to our auxiliary equation. Therefore, m equal to minus 1, 1 are the roots which are real and distinct. The roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then the solution to homogeneous equation looks like y equal to c3 e power 1 root into x plus another root into plus another constant into e power another root into x. So here we are taking c3, c4 instead of c1 and c2 because we want c1 and c2 to appear in the last general solution. Now coming to the solution to the homogeneous equation. The solution to homogeneous equation is y equal to c3 e power 1 root into x plus c4 e power another root into x, or we can write this as y equal to c3 e power minus x plus c4 e power x. Therefore, y equal to c3 e power minus x plus c4 e power x is a solution to our homogeneous equation. Now using this solution, we'll write the general solution to our problem. Let y equal to, now replace the constants or parameters with some functions of x, say a and b. We'll get y equal to a e power minus x plus b e power x, right? Be the general solution to our problem. Or to the given equation, we can say, where a and b are functions of x. Right? We are saying that y equal to a power minus x plus b power x is a solution, is general solution to the given equations. So we can say that y equal to a power minus x plus b power x is a solution to equation 1, which is nothing but it satisfies, right? It satisfies equation 1. So let's find y double dash and substitute y double dash and y in equation 1. Okay. So we are going to find y dash and y double dash using this y. We have y equal to a power minus x plus b power x, right? Let's find y dash. Y dash equals to a power minus x dash plus b e power x dash, right? We need to find derivative of product of two functions. Here also we need to find derivative of product of two functions. So we are going to apply uv whole dash formula, which is equals to u dash v plus v dash u, right? Let's apply this. We'll get a dash e power minus x plus a into e power minus x dash plus b dash e power x plus b into e power x dash, which gives us a dash e power minus x plus a into derivative of e power minus x with respect to x is minus e power minus x plus b dash e power x plus b into derivative of e power x with respect to x is e power x, right? This gives us a dash e power minus x plus into minus minus a e power minus x plus b dash e power x plus b e power x, right? Again we'll get a dash e power minus x minus a e power minus x plus b dash e power x plus b e power x. See, you can avoid this step, this one. Now we can write y dash as, now write the terms involving a dash and b dash. Firstly we'll have a dash e power minus x plus b dash e power x. Now write the remaining terms, minus a e power minus x plus b e power x, right? Let a dash e power minus x plus b dash e power x be 0. Consider as equation 4, so that a double dash b double dash will not appear while finding y double dash. Okay, then the above equation becomes y dash equals to 0 minus a e power minus x plus b e power x, right? Which gives us y dash equal to minus a e power minus x plus b e power x. Therefore, y dash equals to minus a e power minus x plus b e power x. We got y dash here. Let's now find y double dash using this. We have y dash equal to minus a e power minus x plus b e power x, right? Let's now find y double dash. Y double dash equals to minus of a e power minus x dash plus b e power x dash. So here also we need to find derivative of two functions, derivative of product of two functions, right? So we are going to use uv dash formula, u dash v plus v dash u. We'll get a dash e power minus x plus a into e power minus x dash plus b dash e power x plus b into e power x dash, right? This gives us minus of a dash e power minus x plus a into derivative of e power minus x with respect to x is minus e power minus x plus b dash e power x plus b into derivative of e power x with respect to x is e power x. This gives us minus of a dash e power minus x plus into minus a e power minus x plus b dash e power x plus b into e power x, which gives us minus a dash e power minus x minus into minus plus a e power minus x plus b dash e power x plus b e power x. Now write the terms involving a dash and b dash. Firstly, we'll get minus a dash e power minus x plus b dash e power x. Now write the remaining terms plus a e power minus x plus b e power x. Right? Therefore, y double dash equal to minus a dash e power minus x plus b dash e power x plus a e power minus x plus b e power x. So we got y double dash. We have equation 1, y double dash minus y equal to e power minus x sine of e power minus x plus cos of e power minus x, right? Now substitute y dash in it, y double dash, right? Substitute y and y double dash in it. The above equation becomes minus a dash e power minus x plus b dash e power x plus a e power minus x plus b e power x minus y a e power minus x plus b e power x equal to RHS part e power minus x sine of e power minus x plus cos e power minus x, right? This gives us minus a dash e power minus x plus b dash e power x plus a e power minus x plus b e power x minus a e power minus x minus into plus minus b e power x equal to e power minus x sine of e power minus x plus cos of e power minus x, right? So here we can cancel a e power minus x and minus a e power minus x. Likewise, b e power x minus b e power x gets cancelled. We'll get minus a dash e power minus x plus b dash e power x equal to e power minus x sine of e power minus x plus cos of e power minus x. Consider it as equation number 5. Okay. Now by solving 4 and 5, we'll get a dash and b dash. Okay, let's now solve 4 and 5 to find a dash and b dash. We have equation 4 and 5. Now we are going to solve equation 4 and 5 to find a and b, or a dash b dash firstly. So here plus a dash minus a dash, plus a dash e power minus x and minus a dash e power minus x gets cancelled, and we'll get b dash e power x plus b dash e power x equal to e power minus x sine e power minus x plus cos e power minus x, right? This gives us b dash e power x plus b dash e power x is 2b dash e power x equal to the RHS part right. Now take this 2 e power x to RHS, then we'll get b dash equal to 1 by 2 into 1 by e power x into e power minus x sine of e power minus x plus cos of e power minus x. Therefore b dash equal to 1 by 2 into 1 by e power x into e power minus x sine of e power minus x plus cos of e power minus x. Now let's substitute b dash in equation 4 to find a dash. See, we have equation 4, a dash e power minus x plus b dash e power x equals to 0. We can write this as a dash e power minus x equals to minus b dash e power x, right? Write this e power minus x as reciprocal of e power x for our convenience, equal to, now substitute or replace b dash by this. We'll get 1 by 2 into 1 by e power x into e power minus x sine e power minus x plus cos e power minus x into e power x, right? So here e power x gets cancelled, right? Now take this e power x to RHS, we'll get a dash equals to minus 1 by 2 into e power x of e power minus x sine e power minus x plus cos e power minus x, right? Therefore a dash equal to minus 1 by 2 e power x into e power minus x sine of e power minus x plus cos of e power minus x. See, we got a dash and b dash. Let's now find ab. We'll find a using a dash and b using b dash. We have a dash equal to minus 1 by 2 e power x into e power minus x sine of e power minus x plus cos of e power minus x, right? A dash is nothing but derivative of a with respect to x, equal to the RHS part, which remains the same. Now take this differential dx to RHS, we'll get dA equal to minus 1 by 2 e power x into e power minus x sine of e power minus x plus cos of e power minus x into dx, right? Here the variables are separable, so we can perform integration. Integral dA equal to minus 1 by 2 integral e power x of e power minus x sine e power minus x plus cos e power minus x. Right? Actually, you need to write here that the variables are separable. Now, consider cos e power minus x as f of x. Let f of x equals to cos e power minus x, then f dash of x is derivative of cos e power minus x is minus sine e power minus x into inner derivative, that is derivative of e power minus x. Derivative of e power minus x is minus e power minus x, which gives us minus into minus plus e power minus x sine of e power minus x. So we are having f dash of x plus f of x. Okay, since we know that integral e power x of f of x plus f dash of x dx equal to e power x f of x. Okay, so we can apply this formula here, or we can write this as integral dA equal to minus 1 by 2 into integral e power x of cos e power minus x plus e power minus x sine e power minus x into dx, right? Since we know that integral e power x f of x plus f dash of x dx is e power x f of x, so we'll get integral dA equal to minus 1 by 2 integral e power x f of x plus f dash of x is e power x into f of x. F of x is a cos e power minus x plus integral constant, say some c1, right? Or we can write it as a equal to just write as it is. Therefore a equal to minus 1 by 2 e power x cos e power minus x plus c1. Or you can apply chain rule. If f of x equal to cos e power minus x, okay, let e power minus x be some t. Okay, now we can apply chain rule, say df to find derivative f dash of x equal to df by dt into dt by dx. Okay, let's find dt by dx simply by differentiating on both sides with respect to x. We'll get dt by dx equals to derivative of e power minus x with respect to x is minus e power minus x, and we need to find df by dt, right? So if e power minus x equals to t, you'll get f of x equals to cos t, right? So we are having f of x equal to cos t. Now differentiate on both sides with respect to t. You'll get df by dt equal to derivative of cos t with respect to t is minus sin t. Okay, now just replace df by dt with minus sin t into replace dt by dx with minus e power minus x. Since we know that t is e power minus x, so you'll get minus sine of e power minus x into minus e power minus x, which gives us minus into minus plus e power minus x into sine e power minus x. You'll get the same thing. F dash of x will be again e power minus x sine of e power minus x, and f of x will be cos e power minus x. Okay. Again, if you apply the formula, the same thing, you'll get the same thing, and you'll get a equal to integral dA, a equal to minus 1 by 2 integral e power x f of x plus f dash of x is e power x f of x plus integral constant, say c1. You'll get the same thing. Okay, fine. Now coming to b. We have b dash equal to 1 by 2 into 1 by e power x into e power minus x sine e power minus x plus cos e power minus x, right? B dash is nothing but derivative of b with respect to x. You can write reciprocal of e power x as e power minus x into terms under brackets remains the same. Now let's separate the variables, or just write one more step. E power minus x into e power minus x into sine e power minus x plus e power minus x cos e power minus x. Now we can separate the variables by taking differential dx to RHS. Then we'll get dB equal to 1 by 2 into e power minus x sine of e power minus x plus e power minus x cos of e power minus x into dx. So here the variables are separable, so we can perform integration. Integral dB equal to 1 by 2 integral of e power minus x sine e power minus x plus e power minus x cos e power minus x into dx. Let e power minus x equal to some t, right? Now differentiate on both sides with respect to x. We'll get derivative of e power minus x with respect to x is minus e power minus x equal to derivative of t with respect to x is dt by dx. This gives us minus e power minus x into dx equal to dt. We'll just bring this dx to LHS. Then we'll get minus e power minus x dx equals to dt, or we can write this as e power minus x dx equal to minus dt, right? So now let's replace e power minus x with t and e power minus x dx with dt, minus dt. Okay, I'll write the above equation as integral dB equal to 1 by 2 into integral e power minus x sine e power minus x dx plus e power minus x, that is integral e power minus x cos e power minus x dx. Okay, one more step for our convenience. So we'll write this as e power minus x sine e power minus x into e power minus x dx. We'll take 1 e power minus x beside dx in order to replace e power minus x dx by minus dt in the next step. Okay, plus integral cos e power minus x into e power minus x dx. Okay, fine. Now let's replace e power minus x by t and e power minus x dx by minus dt. Then integral dB equal to 1 by 2 of integral e power minus x can be replaced by t sine t, replace e power minus x dx by minus dt, you'll get minus dt plus integral cos t, replace e power minus x dx by minus dt, right? This gives us integral dB equal to 1 by 2 into integral minus integral t sine t dt plus into minus minus integral cos t dt. So here we are having integral t sine t dt, right? So let's evaluate this separately for our convenience. Okay, instead of taking t as variable, I'll take x for my convenience. So I'll find x sine x dx, right? Fine. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du. The integrand is of the form product of polynomial function and trigonometric function. We'll take the polynomial function as u and the remaining part as dv. So we'll have u equal to x and dv equal to sine x dx, right? Now differentiate on both sides with respect to x. We'll get du by dx equals to derivative of x with respect to x is 1. This gives us du equal to dx, right? And here we'll integrate on both sides to find v, which gives us v equal to integral sin x dx is minus cos x, right? Now apply this formula, integral u dv equal to uv, that is x into v, minus cos x minus integral v, that is minus cos x into du, d equal to dx. This gives us minus x cos x minus into minus plus integral cos x dx, right? Which gives us minus x cos x plus integral cos x dx is sin x, right? Therefore, integral x sin x dx is minus x cos x plus sin x. When we replace x by t, we'll get integral t sin t dt equal to minus t cos t plus sin t, right? Since integral t sin t dt equal to minus t cos t plus sin t. Now coming to the above equation, we'll get integral dv b equal to 1 by 2 into integral minus integral t sin t dt can be replaced by the result obtained. We'll get minus t cos t plus sin t minus integral cos t dt is sin t plus integral constant, say c2, right? This equals to 1 by 2 of minus into minus plus t cos t minus into plus minus sin t minus sin t plus c2, right? It gives us 1 by 2 into t cos t minus sin t is minus 2 sin t plus c2. This gives us b equal to 1 by 2 t cos t minus 1 by 2 into 2 sin t plus c2. Here 2 gets cancelled and you'll get b equal to 1 by 2 t cos t minus sin t plus c2. Since t equal to e power minus x, right? Let's replace t. We get b equal to 1 by 2 e power minus x cos e power minus x minus sin e power minus x plus c2. We got b here. Therefore, b equal to 1 by 2 e power minus x cos e power minus x minus sin e power minus x plus c2. So we got a and b. Let's now find the general solution using y equal to a e power minus x plus b e power x. Let's substitute a and b in this. Therefore, the general solution is given by y equal to a e power minus x plus b power x. Now we are going to substitute a and b here. We'll get minus 1 by 2 e power x cos e power minus x plus c1 into e power minus x plus b 1 by 2 e power minus x cos e power minus x minus sin e power minus x plus c2 into e power x, which gives us minus 1 by 2 e power x into e power minus x cos e power minus x plus c1 e power minus x plus 1 by 2 e power x e power minus x cos e power minus x minus e power x sin e power minus x plus c2 e power x. See here, minus 1 by 2 e power x minus x cos e power minus x and plus 1 by 2 e power x minus x cos e power minus x gets cancelled, or you can write e power x into e power minus x as 1. You can just replace e power x into e power minus x by 1 and you can cancel the terms involved in cos e power minus x later. See, if you cancel these two terms, you'll get y equal to c1 e power minus x minus e power minus x, sorry, it's plus x, right? E power x sin e power minus x plus c2 e power x, or you can write this as c1 e power minus x plus c2 e power x minus e power x sin e power minus x. Or if we have not cancelled this, if you want to simplify e power x into e power minus x, just replace e power x into e power minus x by 1, then you'll get y equal to minus 1 by 2 into, you'll just replace this by 1, so you'll get 1 into cos e power minus x plus c1 e power minus x plus 1 by 2 into 1 into cos e power minus x minus e power x sin e power minus x plus c2 e power x, which gives us minus 1 by 2 cos e power minus x plus c1 e power minus x plus 1 by 2 cos e power minus x minus e power x sin e power minus x plus c2 e power x. So here we can cancel minus 1 by 2 cos e power x, cos e power minus x and plus 1 by 2 cos e power minus x. Again you'll get the same thing, c1 e power minus x minus e power x sin e power minus x plus c2 e power x. Then y equal to c1 e power minus x minus e power x sin e power minus x plus c2 e power x, or you can write this as c1 e power minus x plus c2 e power x minus e power x sin e power minus x. Therefore y equal to c1 e power minus x plus c2 e power x minus e power x sin e power minus x is the required solution to our problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.